Located on 85 acres and managed by the City of Santa Rosa's Utilities Department, the Laguna Treatment Plant services a wide geographical area with over 250,000 residents. Since its inception in 1968, our facility has increased the volume of wastewater it treats from 2 million gallons to currently around 18 million gallons daily. More than 500 miles of underground pipes bring wastewater to the plant, where water goes through 3 stages of treatment within a 24-hour period. The recycled water that leaves the Laguna plant is a high-quality, tertiary treated water that is safe from many reuse options. Okay, so in a moment we're going to head over to primary, our first step of treatment, where solids are settled out. And what we'll find is underneath us are 500 miles of underground pipe converging in 5 major trunk lines at the base of the building over here. Now, as we look around the plant, you'll see many buildings and lots of stuff going on. So it's important to note that it takes a village to clean up water, to treat sewage. We've already seen what's going on for support services and administration and lab. Out here in the plant, we have state licensed operators that run this facility. Behind me is the mechanical services. So we've got the electricians and instrumentation and skilled maintenance, and they're taking care of all the pumps and valves and circuits, etc., that all support the infrastructure of this plant. We're going to head over now and talk about primary and visit our anaerobic digesters. In primary, our first step, we're going to see how solids are settled out and removed. So we want to get the majority of solids removed in this step of treatment. And in a moment we'll go into the primary building and see long tanks where solids are settling to the bottom, just like they do in the picture of the cone that I showed you back in the lobby. Okay, once we've got the solids on the bottom, a big conveyor is going to push along the bottom of the tank, move all the solids, and pipe them over to these big round buildings. We have 4 anaerobic digesters, each hold 1 million gallons of solids, and this is where solids are broken down. So in this oxygen-free environment, we have certain types of bacteria and archaea, and they don't use oxygen like we do to burn food molecules to make cellular energy. So as they take apart organic material, they exhale CH4, methane gas, instead of carbon dioxide. And we capture that methane, we blend it with natural gas, and we use it to power 1/3 of our energy here at the plant. And that's very substantial because we're an energy-intensive industry. We can get the water clean, but we have to pollute the air to do it. So when we take the methane natural gas and burn that, we're using carbon that's already out there in the atmosphere instead of burning sequestered carbon. And again, we have to burn a lot because water's heavy. It weighs over 8 pounds per gallon, and we're pumping and lifting and moving some 18 million gallons of water on average a day, and that adds up to a huge expense in our PG&E bill, as well as the pollution that goes along with that. So 1/3 reduction from burning our methane and natural gas allows us to be somewhat sustainable. After about a month of anaerobic digestion, where our microorganisms are decreasing our volume, detoxifying the solids for us, they're going to head over to be dewatered and then loaded up into a hopper. And I'm going to keep you in suspense for the moment about what we do with those solids from there, but we'll go over and talk about that in a bit. In the meantime, we'll head on into primary and see what's happening there. This is our primary building, and the sewage is coming in. We're going to detain it for about an hour and a half in these tanks to slowly let solids settle to the bottom. We're pushing solids along by a conveyor belt back down to the end of the tank. On the surface you see the sprayers. They're pushing the floating kind of greasy solids that aren't readily settling down to the end of the tank, where they can be periodically skimmed off. Now, as the sewage arrives at the treatment plant, it actually goes through a coarse bar screen to remove the largest items, so any type of rags or paper that come in the sewer can get removed. And then we roll the sewage in an aeration tank to make the grit and the biggest solids settle out quickly, So food from people's garbage disposals, etc., is settled out and removed. That small quantity of material is landfilled, and then everything else comes in these tanks to allow all of the dissolved and floating solids to settle. At the end of the tank here, water is collected at the surface where it's cleanest, and it moves to secondary, and secondary is our next stop. We're standing at secondary now, and in between primary and secondary tanks, we can temporarily detain water. So just out of sight, back here are our flow equalization basins, which allow us to bring a constant flow into these tanks, because our system works best when we feed our bacteria a consistent amount of food. During the morning rush, when everybody is using their shower and their sink, that means a pulse of water coming in mid-morning. We can detain water and then bring it back in when we're ready. During those big storm events that we were talking about, where we get storm water into our system, same thing. So once water enters these tanks, you'll notice the water looks really dirty. Well, it is. It's just filthy full of living organisms. So this is where our bacteria, our protists, and our microscopic animals reside, and we're providing them with everything they need to be happy. They've got food, they've got water, and we're bubbling in oxygen. Down in these tanks are diffusers that are blowing air in, so we're providing them with lots of oxygen, because like us, they require oxygen to burn food molecules to make cellular energy. And they're taking apart those carbohydrates and lipids and proteins and nucleic acids, exhaling carbon dioxide to the atmosphere and removing it from the water for us. So removing all that organic material. In addition to the carbon cycling through our system, we also have nutrient cycling, and again, that's done by microorganisms. So you may have detected a faint odor back in primary. That is because one of the smelly byproducts that come from microorganisms is ammonia. And ammonia is created in the sewer. As the sewage travels here, bacteria are already hard at work breaking down nitrogen in organic waste to ammonia, or ammonium ion. And that ammonium, NH3 or NH4, is very toxic, smelly stuff. And so these ammonification bacteria have begun a cycle that will continue in these tanks. Once in here, another suite of bacteria are going to convert ammonium to nitrite and then nitrate. So these are nitrifying bacteria. They're taking advantage of all the oxygen that we're providing them, and they are converting ammonium to nitrate, which is NO3. Now, we don't want a lot of nitrate in our water either, because nitrate is a growth stimulant. So it stimulates the explosive growth of aquatic plants and algae in a process called eutrophication, and we don't want that. So the way that we remove the nitrate is in this area you see here. Notice it's not bubbling like this tank is. That is called an anoxic zone. We're not adding oxygen, and in this area of the tank we have bacteria called denitrifying bacteria. They're not reliant on an ambient source of oxygen. They can get theirs right off of the molecule nitrate. They strip the oxygen off, and then N2 gas goes back to its reservoir in the atmosphere. Okay, so that's the nitrogen cycle happening here. Allows us again to take advantage of a natural process and get those organisms to clean the water for us, removing those unwanted pollutants. Now, at the end of about 8 hours in this system, the bacteria have eaten their full, so we have to settle them out. So secondary is really two parts. The first part is, as you see here, allowing microorganisms to do their job, eat up all the unwanted pollutants. And the second part is right around the corner, so we'll head to the clarification basins and we'll see how we settle out and remove bacteria.